Jain. So we were here in the last session. So we have trained the model actually. So let me check the chat. Okay, somebody says that Tamanna, I still can't download the files from your drive. Is there any other way? No. So why you're not able to download Tamanna? Can you tell me what's the problem? Are you there? Okay, so we'll move forward and then we'll look into it back. Yes, don't know why. Okay. So, because most of them are able to download, so there's no fault from our side. So please check it once again that what is there any erroneous thing that you are doing. So okay. So guys, actually we were here when we were training the model. So we have seen that we have put number of epochs as 10. So here there are two. We have taken Adam as an optimizer. Okay. So and during this break, I have also checked it out with SGD optimizer. Okay. So how you can use stochastic gradient descent optimizer. So in place of Adam, you can replace Adam with SGD, and then you can train your model. So you can see that I'm not getting good accuracy. Like it is here about 50.67. Precision is good, but recall is very bad, and validation loss is very big. Like loss should be less than, actually it should be less than 0.04 or something. So there comes into the picture the CNN, like convolution neural networks, where ANN was not able to extract the features that are very well that will help you to classify the image, like those features that creates contrast between the all these images to identify whether this image is belonging to sea or building or something like that. So these are the classes. So let us do some more codes and then we will look into the regression problem. So I have to tell you two or three lines of codes more. So let us check with the predictions. Like suppose our model is trained. Okay. So the validation accuracy or validation loss you can see over here. So let us check that like we'll take the test generator and then we'll get the prediction. So let x equals to model dot predict. So model is going to predict x test. Okay, and there is no x test. So test generator will write test generator. Okay, and we'll take batch size equals to 1 over here. Batch size, why we are taking batch size as 1? Because we want a separate, like only one, the prediction should be dependent on that particular input. So one input uh, batch size. Okay, so size, yeah. So batch size equals to 1. So let us see what model predicts. So we'll see. So here we have used softmax activation. When you'll see this model that we have created, softmax. So what is actually softmax? So whenever let me use annotation. So suppose this is the input test image. This is test image, and for this test image, the model predicts. So what is the last layer is it has 6 neurons. Okay. So the output will be a vector that will have six six values. Okay. That has 6 values. If we are using softmax, then the 6 values, the sum of all these 6 values will be 1. Okay, that means that the probabilistic prediction is there such that it will tell you that how much it is like first, that is building, how much it is forest, how much it is glacier, how much it is mountain, how much it is a sea, and how much it is a street. Okay, so these six classes for a single image. So it will predict that how much is this among these all six classes. So whatever value will be the highest, like whatever probability value that will come out, and that ranges between 0 to 1, whatever it comes out, the maximum probabilistic value, the probability value that it has given, max 1, we will take it as the predicted class. So 0 is for, suppose here, buildings. So this buildings is 0, forest is the second one, glacier is the third one, street is the last one. Okay. So suppose it says that the third value is 0.51, and the rest of the values are, they are not, they are less than 0.51, but the sum comes out to be 1 because it is softmax. So the highest value is 0.51 for which index? So it is third index, means third class. It predicts as this image is so much like near to this class, which has probability value of 0.51. So in this way, prediction is done. So let us come back and let us do some prediction. Okay. So sorry, this x dot predict whatever we are writing. So x is having like there are six classes. So each x value for each image in the test generator, x will have six values. Okay. So suppose I am writing x0, x0. So what is x0? So x0 has 1, 2, 3, 4, 5, 6, six values. But it is saying that uh, the first one, first index is highest. Just see that 34864, 3485. This is double five. So it says that it says that it is more like the first class, the zeroth class. So how to find which class has what index? So we can write test generator, test generator dot class indices. So it will print like buildings is 0. So it is saying that in the test generator, the very first image was actually building. Okay. So in this way, you can predict whether that particular image, what is the class of that image. So suppose I am taking one test image. So let us take a mountain image. Okay. So I am copying the path of this image. So img test img equals to plt dot im read, and then I'll copy this path. So this test img, so this test img is this image, whatever will be printed over here. Okay, this is the image. Now I need from my model that what is the prediction, like what our model takes it like. So this is what where we have taken it from mountain. Okay. So let us make a prediction. So how to do that? So we have to, because I have already told you earlier that our model takes input in the form of a batch. Okay. So this is 150 cross 150 cross 150 image. Okay. So it needs a batch. Since it is a single image, we will take it as like 1. So 1 cross 150 cross 150 cross 3. So 1 is the batch size. Okay. So how to do this here? Okay, in the code. So what we will do, we have already imported. So import numpy as np. If you have not imported, please import it. Then new img equals to np dot expand dims. So img comma axis equals to 0. So let us see. So the img test img, sorry, this is test img. So test img is having dimension. So test underscore img dot shape is actually 150 cross 150 cross 3, and new img that I have expanded. So new img dot shape is having dimensions 1 cross 150 cross 150 cross 3. So here there is an expansion in the case of batch size. So we have added a batch into this image, and that is of 1. So image is same, but there is a batch. So it is now the input is now ready to be given to this model. So model dot, so we'll write uh, test pred equals to model dot predict, and now we will pass this test img. So new img that is having batch. Okay, yeah. So test underscore pred will print. Now let us find what is the class. So we will use np.argmax. Okay, so np.argmax is something, that function that will give you the highest the index with the highest probabilistic value that is given by the softmax. So np.argmax test underscore pred. Okay, so we will do like this, and then we will get the like class label for that. So it says 2, and what is 2? So it is saying glacier, but it was actually mountain. So if it would have, let us take another image. Okay, so let us take one street image. So I'm taking the path of this image, copied the path, and then this, and I'm running the same code. Okay, so now it is a street, and let us check it out. But it is showing it as what? Building, buildings. Now we'll take buildings image once again last, and let us check. So I need to state that over here that whenever we are training a model, we need to have a feature extractor that will help you identify, that will tell the model like that what are the features in these images that you should consider to train the model. So feature extraction is another very important part, such that in case of CNNs, like convolutional neural networks, the feature extraction is done with the help of like convolution operations, convolution filters. Okay, so they extract the features from these images in a very good way, and when you will apply CNN on the same, like same data set, we'll be able to find it. Yes, it is saying 3 in our case. So it is buildings, and it is saying 3 mountain. So it seems like our model is not trained in a good way. So what you can do is you can have like you can have more this you can add batch normalization over here. Batch normalization layer is there. So I'm giving you the assignment that what you can do. Add batch normalization, then add some layers, okay, and then try to train that model. Batch normalization, just find it out in the Keras library. So Keras batch normalization. Yeah. So you'll find it in the Keras, the batch normalization layer. Okay. So you can add this layer. They will tell you how to add batch normalization. So this is batch normalization. You can add it into your model, train it once again more for more, because we are running short of time, so we are not having that much time to train this model for more than 100 epochs and all that. So you can add this thing and try it out whether your model is performing good or not. In case if it is not performing good, then there will be some CNN sessions on CNN models. So you will have you'll come to know that how you can apply CNN, and then you'll find it that you're getting good result in case when you are applying CNN. So all right, we are done with this session of we have taken 15 minutes more for this session. So we'll do some more things like it will save time for us, because certain steps in the next session are same as compared to this session. So that much amount of time will be saved, and then we'll learn more. Okay. So any questions regarding this session, and then we'll move to another session. So let me clear this, all these drawings, close this. Yeah. Code. Yeah. Shivani, I'm going to share this code soon. Okay. So by this evening, after the second session, the session will be over. By that time, I'll do that. Okay. Any questions? Is there any guideline for number of layers and number of neurons that should be chosen in the hidden layers? No, there is no guideline, but you can see the trend in the recent research papers that whatever code they are using. So the trend shows that initially there are less number of neurons, in the later layer there are more number of neurons, and in case of CNNs, the trend is quite different. It depends on the kernel size and all that. So there is no like thumb rule for this thing. But you can read the latest these research papers, and then you will find it that what the scientists are doing, and what the researchers have gone into, like using empirical research. Like they have done something, changed the parameters, changed the number of neurons in the hidden layers, and then what is the output, and what is the outcome that and what is the actually conclusion out of it. So what should be there in that then the model. So actually outcome of model, it depends totally on the type of data set. So in certain data sets it is doing good, but in other data sets you need to change your model, and you need to change some of the parameters. So it totally depends on the problem that you are going to solve. Yeah, so in the same drive link I'll be sharing this code. Okay. So I'm closing this window, this tab that we have created for ANN, ANN for image classification. Now we are going to use ANN for prediction. This, what kind of prediction? That is regression kind of problem. So we will see the trend, and then we are going to predict that what should be the next thing. So what is actually a regression problem? Can anyone tell me the example of regression problem in the chat? What is regression? Predicting salary based on age. Yeah, very good example. Nice. Okay. Yeah, predicting something based on existing data. This is also classification. So what is so we in basically in regression based problems we used to see the trends in the data. So we are in case of images we are doing classification. We see patterns in that image. But in case of regression based problems we see the trends like suppose in this year what is the electricity like load in the month of May. So in the last year, what was it, and in the before last year, what was it? So we'll see the 10 years trends, and then we can predict that from these 10 years, if the load is increasing, then we can say that yeah, this in this year we'll need more electricity. So in this way, we are having yeah. This is the Avnesh says price of house given house features. This is a very popular problem, and in most of the blogs and most of the you know the books where we are getting examples of regression based analysis, we are getting this kind of data. Okay, today we are going to use a data set that I have already shared with you. Let me go to that data set. So we'll see the chat. Yeah, I'm going to that drive where I've uploaded the data. So this folder lab 23rd June, Algerian forest fires data set. Okay. So again, I'm asking everybody to upload this Algerian forest fires data set updated.csv. Okay. So I'm uploading this in my drive. So I'll ask everyone to go to this drive link, this one that is already shared with you. Please download this data set. Don't try to directly like read this data set from the shared drive. Please download this in your drive, and then we'll make another collaboratory notebook, and then we'll try to run this code. Okay. So let us begin with the new thing that is uh, the regression using ANN. Okay. So first thing is you have to upload the data set. So since no, I haven't uploaded. So I'm going to upload this from my local folder that is already having this data set, and yeah, this one. So so I've uploaded this to my drive. It hardly it will not take so much time. So this is the data set which let us open this data set first. So this is the data set that has months, year, temperature, and there are a number of classes like RH, value, WS, rain, FFMC. These are certain parameters that Algerian forest they have taken the government have taken out this data, and this data is for both the problems like suppose the temperature will take. So we can use this data to predict what will be the temperature. Okay. So there are a number of attributes. We will call it as attributes like features. In case of machine learning, we'll call it as features. So there are a number of features that we will use. We will read and we will try to understand from these features that what is the class. But since we are doing regression, we will take any of these features like except one. Suppose I'm not taking temperature. Okay. So we using these features, we will predict what should be the temperature. Okay. So there is no class of temperature. Okay. There is a value of this temperature. In classification problem, there is a certain we can have a certain value that yes, this is the thing that is needed. Okay. In case of these kind of problem like what should be the value. Okay. So in case of regression, the prediction is a value, and then we will see whether that value matches or not. Okay. So again what we have to do is reading this. So we will create a new collaboratory notebook. So I will ask everyone to create a new collab notebook and write it over there. ANN regression using ANN. So we will rename it as regression using ANN. So I'm going to write it regression using ANN. Okay. So this is my collaboratory notebook. First thing, you already know what you have to do is you have to connect it. So I'm going to connect this drive. Now, since we are not going to do much computation because this is a very simple, like small file, because there were pixels in those images, so the input was very big. Here, input is very small, so we do not need the help of GPU. So I'm going to change runtime type, and from runtime type, okay, so it is already by default it is, and there is no GPU, so it is and there is no GPU. Okay, now first thing is import pandas. So pandas is data analytics tool that is given by the um, uh, that tool, and that is actually that needs Python to run. Okay, so it is written in Python. So that this readily comes with the collaboratory, and you need not install pandas separately. Okay, so I will ask you to import pandas as PD. Second thing, you have to mount the drive. So since it is not mounted, I'm going to mount this drive, connect to Google Drive. Okay, so we will see the update over here. Yes, it is, there is a drive. I'm going into my drive. Inside 23rd June AC, that is inside my drive. And you have to be there where you have uploaded your this thing, the data set. So I'm going to copy path. Okay, and uh, we are going to write df equals to, so in pandas whatever you will read is inside a data frame. We'll call it as data frame. So for we are writing in short form data frame as df. Okay, so df equals to pandas pd dot read. And what kind of file is this? So this is a CSV file. So we'll write pd.read CSV, and we'll give the path of that file. Okay, so it has read that file, and when we will write df, and then we will run this thing, so it will give you that what is the, actually there are how many rows. So there are 122 rows and 14 columns in this data set. Okay, so day 1, 2, 3, 4, and then month, year, temperature, and all these labels are there. Sorry, attributes are there. So day, month, year, temperature, RHWS, rain, FFM, CDMC, and all that. So where did I got this? You can get it from UCI repository. So you can get this in UCI machine learning repository. This data set, you'll find as many data sets you have in your mind. And other than Kaggle, so there are two platforms that we generally use. So first one is Kaggle, and the other one is this UCI repository. Kaggle actually has the data sets that are very challenging because certain competitions are being organized every year, every month, and globally. And they launch their competitions in Kaggle. So you find those data sets that are actually related to the research domain. But in case if you are in a learning phase and you need some of the data sets that are small and just need to have an insight into ML, whatever model you are learning, so you can download the data sets from this UCI data set. Okay, so from here we have found out this this Algerian forest data set. Okay, so UCI machine learning repository. Okay, now I'm coming back. So please let me know anywhere we can get real time data set. Okay, so real time data sets are actually very sensitive data sets. I think so. So in most of the government, in most of the places, they are government sites that are giving you a good real time data set. Okay, and in case there are certain companies that are launching competitions like Amazon is launching and all that, so they are also giving you real time data set, so you can find it in the Kaggle. But most of the time in my case, when we have searched for a particular problem in regression and all that, so real time data set was not available, so you can find it out in the Kaggle. Is it okay? Okay. So I think everybody is here in Pandas. So right, PD. So we are now again getting connected. So PD, you can write in the chat PD. Yeah, if you are doing with me. Avnesh says PD, Visalakshi, Anishka, Madhu. Okay, fine. Now, so with this Pandas data frame, these attributes it considers as actually keys. So df will, when you write df dot keys, like in dictionaries. So dictionaries there are keys. So there is a key value thing. Okay. So here you can see that there is a day, month, year, temperature, RH, WS, rain, FFMC, and these all. Okay. So these are the keys. Now, suppose I don't want a particular thing, like I don't need year. It is of no use for me. Okay. So what we will do is, because you can see that in all the 14, in all the 122 rows, to 2012 is same. Like this value is same. So this value don't have any, any impression on the uh, like the pattern or what we will be extracting using the module. So this is because this is consistent in all these rows, so it don't have any effect on that. So we will remove this column. So what we will do is df equals to, so there will be a new data frame. So df equals to df. In this data frame you have to draw, and which column? So we are dropping year. Okay, so year. Okay, so let us do that. Okay, so it is saying that you have not given access, so you have to pass access. So access equals to 1, because access equals to 1 means column. Now when you will write this df, you will see that year is not present, year has gone. Yeah, so year is not there. Okay, so we have removed year from this data set. Now one more thing. When you'll write like set df dot classes. So df dot dropping means deleting, Shivani. Dropping means deleting. So all the data is in our data frame and we are dropping it. So there will be no year actually. So df dot classes. So here you can see that C is capital. Okay, so we have to write capital. So set df dot classes. So it is giving you set. Yeah, what purpose does access serve? Actually, data frame, in this data frame, it needs access, because whatever the value you are giving, Suppose you are deleting a particular row, then you have to specify that for this particular value you are deleting. But in case of column, you are if you are deleting some column, then you have to specify the axis. So for axis, for row it will be 0, and for a column it will be 1. So what you are deleting, column or row? Okay. There are certain cases, there are certain data sets where there are rows that are specified some with some like a special um, titles. So like that. So data frame has no attribute classes. No attribute classes. Why it is saying? So let us see classes. So set df dot classes. Okay. Okay. So first, yeah, one more thing. Yeah, yeah, I got it. Okay. So when you will, there are certain things like when you are dealing with these kind of data sets, you can see you will not come to know right now, but when you'll like highlight this, you'll see that at the last there is one more space over there. So first, what we will do is we will remove. We will strip the white spaces from these the names of these attributes. So how to do that? So first is we will not look into it first. We'll strip. Okay. So what? How to do that? So df dot column. You have to write df dot columns equals to df dot columns dot str dot strip. Okay. So when you'll see over here, see the classes has space after that. See, just look into it. There's one space. There's one space in front of ws. One space at the end of rain. FFMC is all right, correct. Temperature is all right. Year is all right. Okay, but in certain cases you need to have you need to remove this white spaces already there. That is why it was not able to take classes. Okay, so what you have to do is you have to strip. So a strip actually takes out the white spaces before the column name and after the column name. Okay, so df dot columns. Now, when we will write like df dot keys, so whatever spaces were there like here, they will get removed. So df dot keys. So there is no space. Okay. So all works fine. Now, uh, in case of suppose one more thing. This was the case when the name of the column was having white space. What about these classes? Here you can see that not fire, not fire, not fire is there. But in some cases, let us tell you. Let me tell you that how I can say that. So suppose I am writing set df dot classes. Okay. So when I'll write it, when I'll run it, you'll see that for same fire class, it is giving you three different kinds of labels like fire, and fire. But fire with no space, fire with one space, and fire with how many space? Three spaces. Not fire with no space, not fire with one space, not fire with three spaces. So we need to actually remove these spaces. So likewise, like stripping the columns, we can strip a specific column also. So I'm going to copy this and I'm going to tell you how. So what is the column here? So column is classes. So what we'll write classes equals to df dot classes, and then we are going to strip out these white spaces. Okay. Okay. Now we are going to run this command and let us see is there any difference or not. So there are only two classes it is giving because white spaces has been taken out. So thus there these all three will be the same class, that is fire, and all these three will be the same class, that is not fire. Okay. So in this way, we have taken we have removed the white spaces. Now, suppose I just want to have like suppose I don't want um, day and month. Okay, and I need only RH, WS, rain, FFMC, DMC, DCI, SI, BUI, and all that, FWI. Only these attributes I need. So how I can do that? B- I don't want to actually drop these columns, but I need this in a different another data frame. So how I will do that? So either I can have a list for that. So what how I can do that is x equals to, there will be new list. So df, and then uh, where are the classes actually? So I'm taking these much classes from RH to FWI. So I'm copying this and then pasting it over here. It is saying that I am taking only these much attributes in X. Okay. So now X will have how many keys? So these what were specified, these much keys will be there. What are specified? So there are RH, WS, this rain, FFMC, and all that. Now, suppose I want to predict temperature. Okay. So I want to see that I want that my model should learn trend of these parameters, and it should be able to predict the temperature. Okay. So X will be the input and temperature is actually the label, what it should predict temperature. So we will tell the model, so we'll take it as Y. Okay. So Y will be df, and then we will take it like this, temperature. Okay, this temperature. So x is from df, we have taken from this to this, and we are taking this temperature as the attribute that our model should learn and predict. So this is y. So y has only one key, that is temperature. Okay, so let us print both these things. X, so x has how many columns? 9 columns. And y has how many columns? Only one columns. So for every row, there is a value of temperature. So through these rows, our model will learn, and then it will predict something that should be very near to this y. And if it is very exactly same as y, then our model is perfectly fit for this data, and it will give you the perfect answers. Okay. Now there comes we have the data set. So what is the data set right now? X and y. So this is the actually the I'm making hash over here. So hash is for only commenting. So this is the input feature vector, and this is y is what is the label. Okay. So what is to be predicted now? Now we'll make our model to train on a particular data set. Okay. So one thing you should note that we cannot give the data frame directly to the model. Okay, we need to be we need the data to be this data to be converted into a list. Okay, so iloc I'm not going to use. Yeah, then I'm sure. So how we are going to do that? So this data frame I'm going to convert. X is the data frame right now. So x equals to, we have to import numpy first. So import numpy as np. So I'll run it. So what I'll do, x equals to np dot array x. So x is converted into an array. So now x is data frame, or not a data frame, but it is an array. So x is not a data frame, but it is an array. Same is with the y. So np dot array y. Okay. Now, so we can see the shape. So x dot shape and y dot shape. So yes. Now, as I've already told you in the last session that we have to split the data set into training and testing, but it is not the case of folders where the images are located, but the data is inside an array. So how to split an array into a training and testing data set? For this, we have sklearn. Sklearner is a very good machine learning library where you can find a number of models. So uh, where you can directly use certain like SVM or random forest or and all that. And in case of regression SVC, you can have a SVM regressor and all that. So there are a number of models, a number of tools, a number of libraries that are given to apply it in your data set and keep on learning. Okay, so it is maintained mainly by MIT people. So from sklearn.model underscore selection, so you will find it in sklearn. Import train test split. So this is the function that is already there in the sklearn library. Now we are going to this split this thing. Okay, so what I can do is train split. I'll take in this, I'll pass capital X, that is our data, small y, that is our label. And here seed, in case of seed tests, like split folders we have seen. So here random state is the variable that is actually seed. So we can take 10567 is the seed, any random value, and test size. So here I'm not going to use validation. I'm directly training the model and then we are going to test it. Okay, so test size equals to 0.2. So we are splitting the data in, or I can take one. So okay, so I have to take it into X train, Y train, X test, Y test equals to, oh sorry, Y train. First it will give you X and then Y. So X train, X test, Y train, Y test. Yeah. Okay. So we are having train data set and test data set. So X train dot shape 109 rows are there in X train. So 109 tuples. Okay. So the feature size is 109. Feature vector size is 109. Whole for whole data set. So X train. Now Y train should also have 109. Y train, sorry, Y train dot shape. So it should also be 109. Okay, good. So here it is. Now here I'm going to give you another example to create Keras model using sequential API. So in the last session, we were using Keras functional API, where we were using some layers, and then we were creating the model as inputs and outputs. Here, there's a different way. So from TensorFlow, same way from TensorFlow import Keras. So here, just see what I'm writing. So model equals to Keras dot models dot sequential. So sequential API is the very first API that Keras has given you. So model. So first we in sequential API we are creating model first, and then we are going to add layers on in that model. But in case of functional API, we are creating layers first, and then we are creating the model. Okay. So model dot add. So this is very important thing when you are creating a sequential API. So model dot add. So Keras dot layers dot first is input layer, and in the input layer you have to specify input shape equals to, and the shape is 9. Why 9? Because the size is 9. 9 attributes we have taken. How many attributes? 9 attributes we have taken. So this is 9. Okay. Now model dot add Keras. Uh, this is common. So I'm going to copy that over here, and then dense. And in dense, you have to specify 32. So I'm taking first 32, and activation equals to ReLU activation we are taking. Okay. Then we are giving 16. And then I'm going to use linear activation. Okay. So that let us see what is the linearly what model is learning. Okay. So linear activation. So this is, since it is not a classification problem, so we are not specifying softmax over here. Now, so why I've taken 1? Because this is not a classification problem. We are predicting only one value, that is for temperature. Okay. And linear curve will be there. So linear activation, and let us, okay. Now model dot summary. So this is our model. Okay. Only these much values. Now we are going to first compile the model. So for model compilation, the metrics will be different. So model dot compile. So for compilation loss, we will be using mean square error. So error loss, like mean square error loss function. Optimizer can be Adam, same. So Adam like this, and then matrix. So matrix, since it is a regression problem, so MSE is a very good metric. So mean square error is a good metric. So we are using MSE as a metric as well as MSE as a loss function, and MAE. Okay. Now we are going to we have compiled this model, yes, and then again history equals to model dot fit. But here, because there is no data generator, so we are directly going to give X train, Y train, and epochs. We can have few hundred, like 100 epochs, because it is a very simple model. Batch size we can take 32 because there are this is very small data. Validation split is there. So in case we are giving x train as the input, so we can give a validation split as 0.2 so that our data will get splitted. How do you choose the right activation function in the hidden layers? So ReLU is the most popular, like GALU, ReLU are there. These functions are very good. So we have seen in the literature uh, these functions work very well. So you can use tanH, you can use another other activation functions, but ReLU is good. Okay, so let us see. Yeah, loss is getting down. So for if you like, let us like 1,000 epochs. We are training it. So meanwhile, a model is getting trained. I just want to tell you how to plot something. So we'll create a function def plot prediction. Okay. So model mm, actual. We'll take actual first and then predicted. Okay. Then since we need matplotlib, so we'll try to import matplotlib dot pyplot as plt. Okay, so predicted and then plt dot plot. So what we are going to plot is actually actual. Yeah, actual. And then plt dot plot and then predicted. So simple. And legend. No. So yes, legend we need. So plt dot legend is something we need. Mhm. So it is test data. Yeah, we can take it like test data, comma model plus the name of model plus regression. Uh, Wait. Okay, so model plus and then we will write regression pred predictions. Okay, so we'll do it like this. Yeah. Yes, it should be placed. I think it should be inside this list. So yes, yes. Okay, so this is our function. Okay, so now we are going to have actual we have as y test. So y test is actually this is actual data. Okay, but we need predictions. So y pred is what is predicted on x test. So x test is what is actually you are giving data to model and you need predictions for that. So actual labels are y test and the predicted labels are y pred. Okay. Now we can plot. So we will use this plot prediction. So here we will write linear. Okay, so linear layer will be there, and actual is y test, and predicted is uh, y pred. Let us see. Okay, so you can see that model is not fitting too much here. So since time is not permitting me, I will suggest you something as I suggested in the last session, that use standard scalar. So you can use a scalar because these values are actually taken at, from different distributions. You can see over here. So if you know some statistical some statistical kind of thing. So you can see that rain has values from 0 point and then, but RH is having value integral and all that. So you can convert this data set into a standard way, like if you use some distribution like normal distribution. So according to that, that data set is changed using standard scalar. This is readily it is available in the sklearn. So you can use some scaling of data and then you can apply the same for this to this model, and then you will have better predictions. Okay. So here you can see that the values are the predictions are in case more in this at this point, but here there is a good difference. Okay. So here again this is good, here this is matching. So if you will convert your data into a standard form, so you'll be able to have a good prediction on this data. So I think this MA is mean absolute error, that yeah, this I forget to tell you. So this is mean absolute error. So these are the metrics that have been computed. So I must recommend everyone to this is your exercise, that you should go to this standard scalar and then train it again. So you'll have a good prediction graph over here. So that's all from my side. I think you must have enjoyed these sessions, and I welcome your questions right now. Otherwise, we'll meet again if uh, in the future. Thank you. Definitely, I'm going to upload this code. Yeah. Yeah. So, is this possible to feed different types of variable as input? Yes, yes, yes. It is possible, but I think if there is a variation, good variation, but the distribution is same, so I think there is no problem. But if distribution is different, you can scale up or scale down your data, or you need to have like you, you need to normalize your data first, and then you can apply these kind of training models. So please, before you apply anything on a data, try to first like you need to clean that data first. So how to clean that? By applying normalization techniques, and then there are values that are white spaces there are nan values and all that. So you just need to fix out those values, and then you have to scale your data and normalize your data, and then you can apply them. That is it, Tamanna.